plus 14 from here to here is 62 millimeters, center to center. And then the patient's PD is 59 total, but we're actually going to break it down individually. And the right eye is 29 millimeters, the left eye is 30. And center to center, 31. 31. So, if the center of this person's eye, and the center of this frame, the center of this person's face is 31 millimeters, center of the frame to the center of the face is 31, and we need to move the lenses in a certain direction to get it in front of the person's eye, which is 29, we move it which direction and how much? We move it in 2 millimeters. Left eye, same thing, from 31 to 30, you're going to be moving it in 1 millimeter. And that would be another question that you just throw at. Now, if you want to just do the math and not worry about drawing it out, just take the PD, the frame PD, split it in half, and then subtract the patient's PD. The end, 62 minus, divided by half is 31. Subtract 29, 2 to the right, 1 on the left. I like doing this so you can see how it's done, or if you're having trouble figuring out if it's going in or out or plus or minus. But theoretically, it should be nothing more than your A plus VBL, which is your frame PD, and then take frame PD divided by 2 minus monocular patient PD equals your decentration. That's right from the PowerPoint. So this would be the answer. And then the second question on this, all based from start to finish, so if you get the first one, good, you get credit. If the second one, oh, I'm not quite sure. Well, third one, if we start to lose it, well, it is what it is, but you've gotten part of the credit versus me going straight to question number 1, which would be the lab technician messed up. And they decentered twice what they're supposed to in each eye. How much prism in the right eye? How much in the left? And then what direction? Face. OD and OS. Now, going back here, this sort of throws everything in there. Now, our questions have to go back, and as a matter of fact, I would probably throw another question there. What's the power at 180 in both of these eyes? That way, if you forget the prism and forget the direction, we'll go through, we'll do, let me have more. Does everybody have this top part here? So, we don't need this here. So before we go to that, we'll go to A, and that is power at 180, because remember, when we're doing horizontal, decentration horizontal, you want the power at 180. When we're doing vertical centration, especially things like slab off, you want the power at 90. Well, in this question, we're doing the back and forth distance only. The power at 180 for the OD is how much? Say again? Well, the power of the cell, so if we have, figure this all out, 0, 90, 180. And at 30 we have minus 1. Here, minus 3, so it should be minus 250, check my math. Oh, I'm sorry, thank you, minus 150. Sorry, I'm doing slab off, I'm stuck in slab off. And minus 250. 350, sorry. Give me my Dunkin' Donuts back. This sucks.
Is that is ARPA?
180, 180, 60. Yep. 350. Thank you. I have it. So here's your power at 180 in the OD, power in the left eye, OS at 180. So now, if we decentered it properly, and we put the lenses in front of where they're supposed to be, the right eye is looking through the optical center, the left eye is looking through the optical center, the amount of prism would be none. They're looking right where they need to look at. Well, if we use something like this, where we said, instead of measuring the right eye and decentering it right where it needed to be, I need more room here. So, everybody has that, that's easy. And we know, so we figured out that decentration OD should be 2, decentration OS should be 1. And now we found the power between the two. So now, let's say, for argument's sake, we said the lab tech decentered it twice what they should have. Well, instead of going 2 in the right eye, and 1 in the left, they went 4 in the right eye, which was 2 too many. And they went 2 in the left eye, which was 1 too many. So instead of putting this optical center dead center, here's your optical center of the frame, and we should have gone 2 in, we went 4 in, which we went 1, 2, 3, 4. The optical center now is too far in by 2 millimeters. Left eye, instead of going 1 in, we went 2 in. They're now no longer nose, ear, here. In this particular case here, now we throw in Prentice's rule, and you would look at the right eye. The amount of prism they're looking through is your minus 150 times 2 millimeters, and either convert it if you want or do however you want, and it should be 0.3 prism diopters. And the second question is in what base direction? It is base out towards the ear. This would be your answer. And I may break it out in 2, so if you get the measurement right, that's great. If you get the base wrong, I don't want to kill you for it. Left eye, same idea. You moved it in too far, but this time it's only 1 millimeter. And the power at 180 is a 350 minus 350. In this case, it would be 0.35 prism diopters. Base out again. Those are questions like we may ask. This is a pretty straightforward question. He who's going to the Super Bowl over there, there's always a question like that for the Final Jeopardy because you have to calculate it all out. It's slightly easier than this, but get this down and answer the question, you'll be fine if you get to Final Jeopardy.
Quick question.
Sure.
Can you just write out a Prentice rule for me?
Sure, absolutely.
One of those
The way that, no, perfect. So power times decentration. Now, the way that I always do is I can't stand trying to move in my head the millimeters to centimeters. How did I do it? So I always use the decentration in millimeters divided by 10 equals your prism. What happened?
Your cell phone works inside. You're broken.
Oh, are you kidding?
Probably because you left it on.
Oh, there you go.
Yeah, exactly. Exactly. Carlos is like, take that, jerk. So, your formula for Prentice, now a lot of times they say power times the decentration in centimeters, but then you've got to try to transpose or change into millimeters, and I always hate that because on the fly it always confuses me. So this is my formula, power times decentration. Keep it in millimeters. All we do are millimeters. We don't do it anything else. There's no cubilometer on the face of the planet that does centimeters or even meters for that matter. So if you do the power times decentration in millimeters, divided by 10 gives you your prism. Without question, this will be almost verbatim, just different numbers, will be a question on the test, period. This is important because this is probably one of the most practically important things that we can possibly do. And when we start getting into later on in the semester, we're not only going to be able to determine how much prism was accidentally induced, we're going to be able to tell you whether it's actually acceptable or not. Because not everybody's perfect. Not everybody can get a perfect pair of glasses, and sometimes there are manufacturing errors, and so we will be covering, right after progressives, we'll probably be covering ANSI standards, American National Standards Institute. That is not whether or not it's right or not, but how far off is it, and it may not be good, but is it good enough? In this case, this actually would be fine, and I'll tell you why when we get there. Anyway, so having said all that, this will be a question. Does everybody have this? I saw some people writing. Cool. All right. Oh, prism orientation. This is always my favorite. This one I'm going to go straight back towards one of the old PowerPoints. Yeah, I agree. There we go. So everyone knows the lens cross from start to finish. Everybody should know this. As you're looking at the patient, right eye versus left eye. As you're looking, it always goes 0 to 180, like such, as they're looking at it. So you'd be looking at 0, 90, 180, 0, 90, 180. Well, like this. It's how we're looking at it generally. As a pair of glasses, with the right lens and the left lens. We just went over this, power times decentration. It's in all the power, this lab PowerPoint, I'll put that up as well. I can't stand that centimeter one, obviously. So we've done this already. Don't worry about this. Oh, damn it, I was going to do this extra credit, never mind. So, when we talked about power and direction, this was straight from lab 1, so if you do recall this or not. Most times you're going to see prescriptions with, I saw some of these prescriptions for hourglasses where it had a half base in each eye. A lot of times it'll be out, sometimes it'll be up in one eye, left down on the other, and it's in just one direction. Or, not everybody's exactly symmetrical or like that, you can do up and in, or you can specify it in an axis. And a lot of times, this type of thing, the types of questions I'll ask you is I may give you a picture of a reticle with the sphere and sill lines not centered, and the question will be, how much prism, in what direction? Right eye or left eye, where is it, up and out, down and in, what have you. So if we look at this, and then you can do the axis. This is the one that's sort of important. In the book, the 270, 0, 90, 180, 270. I've always done that as a lab geek, because when we want something that's up and in the right eye, it's going to be specified at between 0 and 190. Generally, if it's 1 up and 1 in, it would be, well, you'd use Pythagoras, and it'd be at 45 degrees, and then figure out that there. Here, in the book, I have to go over this, and I will not test you on this, but they said you can actually do, if you have, I don't know, 270, that's how it would do. Base down would be at 270. 0, 90, 180, 270. They said if you want to use a method that only uses the axes of 0 to 180, you can say base down at axis 90. Sort of stupid, but be aware if you ever see it out in the real world, you may see something. It's not that the base up is normally where we're referring to the base. They said base down at 90 would be the same as 270. I'm not going to throw it at you like that, but if you see a prescription written like that, well, you'll be able to, after this class, figure that out. What I'm concerned about is if I give you a prism axis of 2 base 300 in the left eye, what effect is it going to have? And the 4 choices would be up and in, up and out, down and in, down and out. Well, if we have the left eye, 0, 90, 180, 270, and it's at 300, the prism is going to be down and out. Period. As simple as that. Or maybe something, you have 2 base down. What base is it? And the right eye? Well, right eye and left eye, it doesn't matter if it's straight up or straight down. It would be 270. Something like that. So, go on.
Would it make difference if the lens is like plus or minus?
Yeah, ha 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 ha. It wouldn't as you're looking into it, but it will matter which way you move the lens to get there. And that's, so if I have a plus lens, great question, because that also is a huge fair game. And so I have a +2, and I decenter, so given my +2 lens, and it's right in front of the eye. Right eye. And I want to induce or cause, on purpose, vertical prism. Not accidental, but you want to do it because of some type of binocular dysfunction. And you want 1 prism diopter, base up. How far? And in which direction would you move this lens from the center, from the frame optical center, from the frame center, from in front of their eye? So here we're going to have our little dude with blue eyes, my son, and we're going to break out our handy dandy and let's say +2. If we're talking about side to side, I would do it this way. I'm doing it up and down. I would do this way. So if I have this dead center, right on the pupil, and I have this dead center, which way would I move this lens to get my base up? Move the lens up. So, in this case, I already know that I'm going to move it which direction? Up. And now, how far? If I want 1 prism diopter, or if we go back into our power, almost, how many millimeters? Times decentration in millimeters divided by 10 equals prismatic power. Now, in this case, we already know I have a +2. I want the decentration in millimeters divided by 10. And I know the prism I want is 1 prism diopter. Get the idea? So if I do this, divide both sides by half. Did that just go out again? Oh. What's going on in there? The answer would be you're going to move that +2 lens 5 millimeters up to get what you need. And the easier way to look at this is I always use things in tens. If I move this plus lens 10 millimeters up, 2 times 10 divided by 10 is 2 prism diopters. I want to move it 1 prism diopter. I'm going to go half that, 5 millimeters. That's easier for me, but this is the right way to do it. I can't